Hi, I'm Dave again from Physics and Astronomy at Purdue, and my friend Bill is here somewhere helping out, maybe behind the camera. We're going to talk about centripetal force. So let me give you an example. A car in a roundabout. You're in a car in a roundabout, and as you go into the roundabout, what do you feel? Which way does your body want to move, or which way is your body inclined to move? To the outside. So as the car, let's say, curves to the left, your body, by Newton's laws, is going to want to continue to go straight. And as a result, you're going to pull to the outside. Similarly, let's take, for example, a mass on a string. So here's a mass. And if I swing this mass around, if I don't hit myself in the head, I will feel a force on that string. And if I move faster, I'll feel a stronger force. And if I put less mass, I'd feel, what do you think? A lesser force. So we have a device here designed to measure those forces. And we're going to take a closer look at how to get started using this device. Our centripetal force device has a spring scale that measures in pounds and newtons. We're going to use the Newton scale. If I apply a force, you notice that I can measure that force directly. Well, if we're swinging the apparatus, if we're swinging a mass in a circle with the apparatus, the greater the force, the more that scale will pull, and that will have the effect of increasing the radius of the circle. And I'd like to maintain a constant radius. So here's what I'm going to do. I'm going to make some marks on the pole to compensate for these about 1 inch or so increments in increase in radius. So let's loosen the thumb screw. I'm going to hold the scale at 0, and I'm going to make a mark. And you can see the mark. Now I'm going to pull to 1 Newton, and I'll make another mark. And I'll pull to 2 Newtons and make a third mark. 3 Newtons, 4 Newtons. Now, as I swing the mass around beyond 1 Newton, I will adjust where the scale sits to compensate for that slight increase in radius in order to maintain a constant circumference. We have 2 masses that we will use in our experiment, 2 different stoppers. We need to know the mass of each. So let's take the heavier one at 57.47 grams and the lighter one at 23.41 grams. Okay, we're ready to start our experiment. So we have several variables here. We have mass, we have a radius, we have force. We're going to maintain a constant force and measure other parameters relative to that force. And so I'm going to have my colleague step in and do this experiment based on this setup.
Hey, David.
Yeah.
According to the lab, it says we have to come up with the circumference, and I know we did the markings earlier, but we haven't measured the circumference yet, correct?
That's correct. Do you want to come and help me with that?
Sure.
Let's just get from the tip of the glass rod down to the bottom of the stopper. What have you got?
74 centimeters.
74 centimeters. Okay, then let's get started.
Okay, David, so I have the apparatus here. Now, what are we doing?
Okay, Bill, you want to swing the apparatus, swing the mass to make revolutions with a constant force of 1 Newton.
So I got to swing this around my head and keep the dial right at 1 Newton.
That is correct.
Okay, and we're going to do that for 30 revolutions, and you're going to time me?
I'm going to time you for 30 revolutions.
Okay, so I'll tell you when I'm going, and then you start the stopwatch.
Okay, sounds good.
All right, David, I'm at 1 Newton.
Okay, then start counting.
Nine, 30.
All right, that was 19.95 seconds.
So now we have to adjust this down so that we can, and we're going to go halfway between the lines since we're doing a half a Newton. So now I'm going to do 1.5 Newtons, and we're going to do the same thing, correct?
That's correct.
All right. I'll tell you when I'm at 1.5 Newtons, and you can start the stopwatch. All right, David, I'm at 1.5 Newtons.
Okay, start.
26, 27, 28, 29, 30.
All right, 18 seconds.
All right, I'm going to go ahead and adjust it down to 2 Newtons.
Okay,
I'll tell you when I'm at 2 Newtons, David. I'm at 2 Newtons.
all right, start counting. Okay, that was 16.7 seconds.
Okay, I'm going to adjust it again for another half. So now I'm doing 2.5. Is that right?
That's correct.
Okay. So I will tell you when I'm at 2.5, and you can start the stopwatch.
Okay,
I'm at 2.5.
okay, start.
You count out loud, Billy. 3, 5, 6, 7, 8, 9, 30.
All right, 14.5 seconds. It's easier for the timekeeper if you count out loud.
I'm trying to make sure I keep my count good. So now I'm going down to 3, correct?
You're going to go to 3 newtons.
All right. So I'm at my 3rd mark. All right. So now I go 3 Newtons. Here we go. All right. I'm at 3 Newtons.
Okay, Bill, start counting.
2, 3, 4, 5, 6, 7, 8, 9, 30.
All right, that was 13.5 seconds.
All right. So going down one more, another half to 3.5 Newtons.
Bill, I got a question for you.
Yeah.
What do you think would happen to the velocity if we put a heavier mass on the device and maintain the same force?
I think it would go up.
That's an interesting question.
I would think. Well, we massed out 2 of these, so we could try that with the other mass, right?
We can.
We're using the smaller mass right now.
What do you think would happen to the force if we put a larger mass on and maintain the same velocity?
I don't know. That's a good question.
What do you think would happen to the radius if we put a heavier mass, maintain the same velocity?
Get bigger. It's going to have more of a pull. It's bigger force.
Okay? These are things that we could figure out. Anyway.
All right, so we're 3.5?
3.5. Are you ready to go?
Yeah, and thank you for giving me a break so that way I could breathe a little bit.
Sure.
I appreciate that.
Okay.
All right, here we go.
Ramp it up.
All right, I'm at 3.5.
Okay, start counting.
2, 3, 4, 5, 6, 7, 8, 9, 30.
13 seconds. 13.0.
Wow. All right, now we're at 4 Newtons. And I know you're not sitting right next to me, David, but it definitely makes a different sound when we go faster. Or when we're doing more Newtons, more force. All right, ready?
I'm ready.
All right, I'm at 4.
Okay, then start counting.
5, 6, 7, 8, 9, 30.
12 seconds.
Okay, so a couple questions you asked were, what if we change the mass of the stopper? So here's our other stopper, the small one. Now I put the bigger one on, and you guys have the mass from that before. So now we're going to do the same runs again, and this time with this stopper. So right now I have it set at 1 Newton, according to our little notches. And I'm going to get this swinging, David, and then you tell me, I'll tell you when I'm at 1 Newton, and you can start the stopwatch.
Okay, that sounds good, Bill.
All right, 1 Newton.
Okay, start.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30.
Okay, we have a time, Bill, of 32.2 seconds.
Okay, I'm going to adjust it down to 1.5 Newtons.
We notice a distinct difference, don't we, between the velocity and well, the velocity and the number of revolutions.
How long it takes.
Yeah, how long it takes.
All right, so here we go, 1.5 Newtons. All right, ready to start the stopwatch?
I am ready.
Go.
Start.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30.
27.4 seconds.
All right, going down to 2 Newtons.
2 newtons.
Here we go. And I'm ready when you are.
Okay, start counting.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30.
24.1 seconds. Are you getting dizzy yet, Bill?
A little bit, looking up, but you know what? All in the name of science, David. All right, we're now at 2.5.
2.5. 2.5 newtons.
All right, I'm ready.
Okay, I am ready to start.
6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30.
22 seconds.
All right, now we're going down to 3. All right, ready?
I'm ready when you are.
All right, I'm at 3.
Okay, start.
6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30.
20.4 seconds.
All right, 2 more runs. 3.5.
3.5 newtons.
All right, here we go. All right, I'm ready.
Okay, start now.
2, 3, 4, 5, 6, 7, 8, 9, 30.
19.5 seconds.
1 more. Ready?
I am ready when you are.
All right, I am at 4.
Okay, go.
4, 5, 6, 7, 8, 9, 30.
17.7 seconds. All right, Bill, what do you think we should do now?
Answer the questions on the lab? No, not yet?
Let's do one more experiment.
All right, what's that?
Let's try the same mass
Okay.
with a larger radius. So that means we're going to have to slide the scale up a little bit. We'll have to recalibrate the marks on the shaft of the device. So let's try that. We'll recalibrate it, and let's do that experiment.
Okay. Okay, so we're doing the new one with a new radius, so we need to measure this, right?
Yeah, let me grab a meter stick, Bill. Are we doing this in inches or centimeters?
We're in science class. We're using the metric system.
Oh, okay.
we're
So from the tip of the glass rod to the bottom of the stopper is 87.5 centimeters.
87.5 centimeters.
We
Perfect.
good?
Yep.
Okay.
So while you're writing that down, I'll go ahead and I'm going to adjust this because this was set at 0. Now I'm at 1 Newton. Or am I supposed to be at 0.5 newtons?
No, let's start at 1 Newton. That's what we did before.
Okay. So I'm at 1 Newton, and I'm going to do the same thing. I'm going to swing this above my head, and I'll tell you when I'm ready. You got your stopwatch ready?
I'm ready when you are.
All right, I'm at 1 Newton.
Okay, start counting now.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30.
34 seconds, Bill.
David, that was almost hard to keep it going. All right, so now we're going to 1.5.
We're going to go to 1.5 newtons. So I'm rounding these to 3 significant digits, 1 decimal point, just so you know. So that was 34.0.
Awesome. All right, so now I'm at 1.5.
I'm ready when you are.
It went right to it. Ready.
Okay, start now.
3, 4, 5, 6, 7, 8, 9, 30.
That is 29.9.
29.9. All right, so now we're at 2.
2 newtons.
Here we go. All right, I'm at 2 newtons.
Okay, start counting now.
1, 2, 3, 4, 5, 6, 7, 8, 9, 30.
All right, 25.2.
All right, 2.5.
Let's go 2.5.
All right, I'm at 2.5.
All right, start now.
23, 24, 25, 26, 27, 28, 29, 30.
23.6 seconds, Bill. You ready for, what's the next one? 3 newtons.
3.
Okay,
Ready?
okay, start now.
29, 30.
21.4 seconds.
3.5.
You know, the students that are watching this are missing all the fun.
Yes, they are, but I'm getting a little bit of a workout, which is good. All right, here we go. 3.5.
3.5 newtons. I'm ready when you are.
All right, now I'm ready.
Okay, start now.
21, 22, 23, 24, 25, 26, 27, 28, 29, 30.
20.9 seconds. Bill, what do you feel when you do this?
Well, I tell you what, definitely difference between the smaller one and this one. I can feel the force.
Good answer, Bill.
Here we go. 4. All right, I am at 4.
Okay, start now.
21, 22, 23, 24, 25, 26, 27, 28, 29, 30.
How about 19.8 seconds? Hey, I think we're done, Bill.
Now can they answer the questions, David?
Now we can answer the questions.
Awesome.
Thank you, Bill.